So Sarah Withee will be speaking for the first one, and this theme is techniques for resource evaluation with a focus on relevance to potential inclusion in resource campaign. So techniques is what this one will be on. Sarah, it's all yours when you're ready.
Great. Okay, thank you. So what I'm going to be talking about is factors affecting robotic mapping of ice resources in permanently shadowed regions. And this is something that the Position, Navigation, and Timing subgroup of the Lunar Surface Innovation Consortium held a series of meetings about earlier this year. And our goal was to figure out if we are going to send a robotic prospecting mission into a PSR, what's the state of the art now, and what are the technologies that we need to develop in order to make this happen? And so today I'm going to summarize some of our findings in those discussions. So the first thing is, where are these ice resources located? And that's going to be a critical issue, because if our robots, if the ice is in the floor of the crater, great, that's easy. We've got the technology well developed to access that. However, if the ice is located in the sides of the crater where it's steep, the robots right now, wheeled robots, have a hard time accessing those types of places. And that would mean if we are going to be examining those areas, we need to develop alternative mobility types, such as tethered robots, possibly hopping, maybe even snake type robots. And we will need the navigation sensors and the algorithms that will allow these to move around. Second is environmental constraints on navigation sensors. State of the art, currently, most robots rely on visual sensors to figure out where they are and where they're going. And visual sensors are going to encounter a lot of challenges in PSRs, lunar dust being one, darkness, extreme contrast between light and dark areas, and extensive shadows. And so that means likely we're going to need to develop either visual sensors and processing algorithms that can handle these types of challenges, or we may need to look at alternative technologies that are not visual, such as radar. And a third factor that will influence a robotic ice mapping mission is the extent of the territory that we need to survey. So, Viper is, I think, got a top speed of about 0.5 mile an hour. And so obviously, if you're surveying several kilometers of territory, ideally you'd want to be able to go faster than that. And it would be hard to survey that much with a single rover is the other thing. And so we're hoping that robots eventually are going to be able to make more of the decisions themselves about where they're going and how to get there, and that would speed up the process. Carnegie Mellon is actually sending a mission called Moon Ranger on an upcoming CLPS flight, and their goal is to have the robot cover a couple of kilometers a day without any communication from Earth. And finally, also related to the extent of territory, is having multiple mobility types and teams of robots for a prospecting mission would be a real asset. You could get to more types of territory, you could cover terrain more quickly, and if you could get these robots to work together, you could speed things up and go to areas that you otherwise wouldn't be able to access. So in conclusion, future robotic lunar resource prospecting would be advantageous to have multiple mobility types, modifications to existing navigation sensors, increased robotic autonomy, and consequently new approaches to mission ConOps that can deal with the increased autonomy. So thank you for your time.